Hey, welcome to lesson 28. This is scientific notation for large numbers. And objective number 1 is to use scientific notation to represent large numbers. Alright, so a couple things we need to know. First of all is the definition of scientific notation. Okay, scientific notation is a method for writing really big or really small numbers. And today we're going to talk about the really big variety. Okay, so let's say like you had a number in the 10 trillions. Okay, that'd be a lot of zeros afterwards. So there's a way to write this shorter. That's what scientific notation is. It's a way to write numbers with a lot of zeros in a shorter way. Okay, so here's the format for scientific notation. Okay, you're going to have some number right here. Okay, and that number has to be at least 1 and less than 10. Okay, so it can't be 10, it's got to be less than that. It's like 9 or 9.9. Okay, it could be 1, but it's got to be at least 1, meaning 1 or bigger. Okay, so it could be 1, 1.1, 1.2, but it's got to be at least 1, but less than 10. Okay, so this number right here has to be at least 1, but less than 10. A lot of times it's going to be a decimal number, like 5.2 or something like that. Then you always have times 10. Okay, always have times 10, and this is to some exponent. Okay, and what the exponent does is it tells you how many places to move the decimal. And we'll talk about what that means. So how many places the decimals, or whoops, decimal, sorry, not decimals. How many places the decimal moves. That's what the exponent tells you. Alright, and we'll talk about that in just a second. So, before we can talk about scientific notation, we need to understand place value here. Okay? And what we've got here is a table that tells us we've got numbers in the hundreds, so like ones, tens, hundreds. Okay, so this is 100 right here. And then we've got the thousands, so we got 1,000s, 10,000s, 100,000s, and so on, all the way out to trillions. And what this tells you is what power of 10 is represented by these. Okay, and here's what that means. So ones, that is just the number 1. Okay, so 10 to the 0 power is 1. 10 to the first power is 10. And 10 to the second power is 100. Okay, now if you look at the pattern here, what happens is there's no 0 here. So this tells you that there's 0 zeros after the number 1. This says there's 1 0 after the number 1. So 10 to the first power is 1 followed by 1 0. 10 to the second power means there's 2 zeros after that number. Okay, so 1 followed by 2 zeros. And this should make sense because think about what exponents mean. You remember what 10 squared means? That means 10 times 10. Okay, and that's 100. So this one would mean 10 times 10 times 10. And that's the same as 1 followed by 3 zeros, which is 1,000. Okay, 10 to the fourth power is 10 times 10 times 10 times 10. Whoops, sorry. And that's the same as 1 followed by 4 zeros, or 10,000. And this one right here, 10 to the fifth power, that's 100,000, or 1 followed by 5 zeros. It's 10 times itself 5 times. Okay, and the pattern could go on. Okay, I'm going to stop at 1,000,000 because otherwise we could fill this table out forever. But 10 to the sixth power, that means 10 times 10 times 10 times 10 times 10 times 10. That's 1 followed by 6 zeros, or 1,000,000. Okay, again, so we got our place value here when the millions, 1,000,000, 1 followed by 6 zeros. Then we'd have 10,000,000, it'd be 1 followed by 7 zeros, and so on. Okay, so we got to understand place value for scientific notation. Now let's do some examples of what scientific notation actually looks like. Okay, so here's an example of when we would want to actually use scientific notation. It says the speed of light is about 300 million meters per second. Okay, and a lot of scientists and astronomers and things like that use scientific notation because they have to deal with really huge numbers with lots of zeros. And instead of writing out all those zeros, there's a simpler way to write it for scientific notation. Okay, well, 300 million is the same as 3 times 100 million. Okay, that's just another way to write it as a multiplication problem. 300 million is 3 times 100 million. Well, scientific notation, if you remember, we want to rewrite this number, okay, and we want to rewrite it so that we have a number between 1 and 10 to start with. So what I'm going to ask myself when I do scientific notation is where could I put a decimal in this number to make it between 1 and 10? Well, I can't put it like here because that would be 300 if the decimal goes after that. But if I put it right here after the 3, okay, that would make 3.0 with a lot of zeros after it. Okay, that's the same as 3. So my number between 1 and 10 is 3. Then I said we always have times 10 to some power. Okay, well, I'm taking 3 times 100 million. If you look down at your table here, 100 million is 10 to the 8th power. Okay, so there's our scientific notation for 300 million. And we can check this because remember I said in the first slide that this exponent here tells you how many places to move the decimal. So if I put a decimal point in 300 million, okay, if I rewrote 300 million, and I put a decimal in there, okay, to make it 3, so here's my 3, I put 3 and then the decimal right after it. This number tells me how many places I should have to move the decimal to get to my original number. Well, I'd have to move it 1, 2, 3, 4, 5, 6, 7, 8 places to get to the end of that. Okay, so that's where this 8 comes from. So this right here is another way to write 300 million with not so many zeros. Okay, so you could probably see how this would be really handy if you had a number that had like 27 zeros after it. Okay, so let's go on to another example. Okay, so now here we go. We got some steps to writing scientific notation. We'll do another example, and here's some steps that we can follow. Okay, the first one is to place a decimal in the number to make it at least 1. That's key, at least 1, but it's got to be less than 10. Okay, so it says the Earth's average distance is 93 million miles. Okay, the average distance from the Sun is 93 million miles. We want to write that in scientific notation. So the first thing we need to do is write our number, 93 million. Okay, now we need to be able to put a decimal in here to make a number that's at least 1 but less than 10. Well, if I put a decimal here, that's 0.93. That's not at least 1. So my decimal can go here, and that would make it 9.3. Okay, so I'm going to go ahead and insert a decimal here. And I'm going to take that number, 9.3, and write it down here. Okay, remember scientific notation is always times 10 to some power. And the power that we're going to put here, the exponent, is going to tell us how many spaces I have to move this decimal to get to the end of my number. So step 2 says, after we figured out what number, where to put the decimal, we have to count how many numbers are after the decimal. So I've got 1, 2, 3, 4, 5, 6, 7. Okay, so that means my exponent is going to be 7. And there's my answer in scientific notation, 9.3 times 10 to the 7th power. Okay? And let's do one more example. Okay, this example says, when Britta finished the 1,500 meter run, she announced that she had run 1.5 times 10 to the 6th millimeters. Okay? We want to write that number in scientific notation and then in standard form. Okay? When we write it in scientific notation, we're going to write it just like we read it. So it says 1.5 times 10 to the 6th millimeters. Okay, that's scientific notation. 1.5 times 10 to the 6th power. Okay? So that's how many millimeters that she had run. Well, now we want to write that in standard form. Okay? And to write it in standard form, I'm going to rewrite it in scientific notation. And remember what we said about scientific notation. Okay? This number right here tells me how many numbers should be after my decimal point, or how many places to move this decimal to get to my actual number. Okay? So the way I'm going to do this is I'm going to write 1.5, and I need to move my decimal over to the right 6 times. So I'm going to count 1, 2, 3, 4, 5, 6. Okay? And what that's going to do is that's going to put my decimal clear out here at the end instead. Okay? So I'm not going to have any numbers after my decimal. So now all I need to do to write it in standard form is write the 1 and the 5, and then all these little loops need to be filled in with zeros. So I need 1, 2, 3, 4, 5 zeros afterwards. And then I need to put commas where it's appropriate. And of course label it. So that means she ran 1,500,000 millimeters. Okay? So again, if I wanted to check this, if I had my decimal back here between 1 and 5, this 6 tells me how many numbers would have been after the decimal. So you can look there and see that there are 6 numbers after that decimal place. Alright, if you got any questions on scientific notation, ask. Otherwise, good luck on your homework.